Hi guys, welcome back to my channel. In this tutorial, we're looking at the integral of the square root of 5 minus x squared dx. So let's dive into it. With this one, we can use a trig sub. So I want to start off by doing the obvious. So if we let, why this won't work, if we let x be equal to sine of theta, 5 sine of theta. Will this work out? Let's try it and see. Let's find the x, the theta, which is equals to 5 cosine theta, implying that the x is equals to 5 cosine theta, the theta. So it means wherever we see x, we plug in sine 5 sine theta. Wherever you see the x, we plug in 5 cosine theta, the theta. So if we take everything from the x world into the u world, that should be 5 minus x squared. X is 5 sine theta. You square that, the x is 5 cosine theta d theta. So this simplifies to the integral of the square root of 5 minus 5 squared is 25 sine squared theta, then 5 cosine theta d theta. The problem is here. 5 and 25 are not the same. So we can factorize that one and have 1 minus sine squared theta, which you can easily substitute with cosine squared theta, the Pythagorean identities. So using x to be 5 sine theta, we are not able to solve this integral. So the substitution 5 sine theta as the expression for x is incorrect. How do you fix that? Well, fix that. So we can let, instead of x to be equal to 5 sine theta, we can let 5 equal to the square root of 5 sine theta. And hope for the best. I think this will work out nicely. Now, the x, the theta, is equals to square root of 5 cosine theta, implying the x equal to square root of 5 cosine theta d theta. So we can take everything from the x world into the u world. So the integral of the square root of 5 minus x squared dx is equal to the integral of the square root of 5 minus x squared. X is square root of 5 sine theta squared times dx. Dx is the square root of 5 cosine theta d theta. This simplifies to this is a constant, it comes in front. The integral of the square root of 5 minus square root of 5 squared is 5. Sine theta squared is sine squared theta times cosine theta d theta. This further simplifies to square root of 5. The integral of the square root of 5 is common in both sides. We have it's common here and it's common in this term. Factorize out that with 1 minus sine squared theta times cosine theta d theta, which further simplifies to square root of 5. The integral, this can be split into the square root of 5 times the square root of 1 minus sine squared theta times cosine theta d theta. Simplifies to, this is a constant, it comes in front, so that should be the square root of 5 times the square root of 5 in front. Then the integral of the square root of 1 minus sine squared theta is cosine squared theta times cosine theta d theta. This is gotten from the trig identity, which is very obvious. Sine squared theta plus cosine squared theta equal to 1. So cosine squared theta is equal to 1 minus sine squared theta. So it means wherever we see sine squared theta, 1 minus sine squared theta, you can just plug in cosine squared theta. So this square root of 5 times itself is 5. The integral of the square root of cosine square theta is just cosine theta times cosine theta d theta. This simplifies to 5. The integral of cosine square theta d theta. So our original integral, which is the square root of 5 minus x squared dx, has been reduced to 5 integral cosine square theta d theta, using the substitution, using x to be equal to the square root of 5 sine theta. So our task now is to evaluate the integral of cosine square theta d theta. When we get that, we can multiply by 5 and then turn everything into the x world using this expression. So how do you integrate cosine square theta d theta? So we know that cosine 2 theta is equals to cosine square theta minus sine square theta. And we know that sine square theta is equals to 1 minus cosine square theta from Pythagorean identity. Can plug that in. Cosine 2 theta is equals to cosine square theta minus 1 minus cosine square theta. This simplifies to cosine 2 theta is equals to 2 cosine square theta minus 1. So we can isolate cosine square theta, so that should be 2 cosine square theta is equals to cosine 2 theta plus 1. We can divide by 2 on both sides, and we have cosine square theta is equals to 1/2 cosine 2 theta plus 1. So instead of integrating cosine square theta, which is currently not integrable, we can just replace that with 1/2 cosine 2 theta plus 1, or multiply by 1/2. I can switch back to mark pen. So we now have the integral of cosine square theta d theta, which is equal to the integral of 1/2 cosine 2 theta plus 1 d theta. So this can be split into 1/2 integral of cosine 2 theta plus the integral of 1 d theta. This is 1/2 the integral of cosine 2 theta d theta plus integral of 1 in the theta world is just theta. Our task now is to integrate this. So we can use a u sub, can let u to be equal to 2 theta. Du d theta is equals to 2. Then du should be equal to 2 d theta, implying that the theta is equals to du over 2. So our integral now becomes 1/2 the integral of cosine 2 theta. 2 theta is now u, so we have cosine u times d theta. D theta is du over 2 plus theta. We already integrated 1 in the theta world, which is theta. So this simplifies to 1/2 into 1/2 is a constant. It comes in front of the integral. Then you are integrating cosine u in the u world plus theta. This simplifies to 1/2 times 1/2. Integrating integral of cosine u is sine u plus theta. But what is u in terms of theta? u is equal to 2 theta. So you can just plug that back in. So that should be 1/2 into 1/2 sine of 2 theta plus theta. Can distribute our half, so that should be 1/4 sine 2 theta plus 1/2 theta. So this is the integral of cosine square theta. Therefore, it implies the integral of cosine square theta d theta is equals to 1/4 sine 2 theta plus 1/2 of theta. But what is our original integral? Let's go back up. Our original integral, which is the square root, the integral of the square root of 5 minus x squared dx, was equal to 5 times the integral of cosine square theta, that is here. So we just have to multiply that by 5. Our original integral, which is the integral of 5 minus x squared dx, is equals to 5 times the integral of cosine square theta d theta. This is by using the substitution x is equals to the square root of 5 sine theta. So it implies that the integral of the square root of 5 minus x squared dx is equals to 5 times the integral of cosine square theta d theta, which we just found here, times 1/4 sine 2 theta plus half of theta. So this can distribute 5/4 sine 2 theta plus 5/2 of theta. Now we have to move back from the x world, the theta world, into the x world, because our original integral is in terms of x. Our final answer is in terms of theta. So we have to move from the theta world into the x world. So we have to find what theta is, but we know that x is square root of 5 sine theta. If x is the square root of 5 sine theta, then sine theta is equals to x over the square root of 5. And that implies that theta is the arcsine of x over the square root of 5. So it means wherever we see theta, we just plug in arcsine of x over the square root of 5. And that should be 5/4 sine of 2 theta. Theta is sine inverse of x over the square root of 5 plus 5/2 theta. Theta is sine inverse of x over the square root of 5. Therefore, the integral which we are asked to evaluate is 5/4 sine of the angle 2 sine inverse of x over the square root of 5 plus 5/2 sine inverse of x over the square root of 5 plus the constant of integration. So this is the value of this integral. So you can verify that by taking the derivative of this. Take the derivative of this and work out, should be able to arrive at our original integral function, which is the square root of 5 minus x squared. So that's it. If you find this video helpful, make sure to like the video, hit the subscribe button, and hit the notification bell for more content like this. Thank you so much for watching, and I'll see you in the next one. Bye bye.